Welcome to Unit 1, Lesson 3, where we're going to continue talking about factoring and discuss two new methods, substitution and grouping. But take a few minutes and first try the warm-up activities at the top of this note, and then use the completed version of the note to check your results. Once you're ready, we're going to jump together to the actual new stuff of this lesson, which are substitution and grouping skills. So this first thing called substitution, we're going to essentially try and use the same factoring skills that we reviewed in our previous lesson as much as possible, but in order to be able to do that with some more complex polynomials, we sometimes need to make a little substitution to make it happen. Let's see how this works. So if we look at example 1a here, one thing that we might notice is that each of these two big pieces that we're dealing with, and when I say two big pieces, I mean we have this term all stuck together, and we have this term all stuck together. So each of those two big pieces have something in common. They each have this exact same bracket, x plus 1, attached to them. So we can actually make this a simpler thing to work with and a simpler thing to factor if we make our substitution based on that. So here's what I mean by making a substitution. We're going to come up with a brand new variable. And it really doesn't matter what the letter is, but I'm just going to use y because it's another commonly used variable. And what I'm going to do is I'm going to say, let's let, or in other words, pretend that y is equal to x plus 1. And all I'm saying there is that from now on, every time I see an x plus 1, I'm going to just replace it with a y and call it y. So let's rewrite the original expression and see what that's done. So suddenly this is going to become 6x times y, because that's what that x plus 1 is doing now, minus 2y. From here, now I've actually got something that I can do some factoring on. The original expression, I couldn't really use any of the skills from my previous lesson to factor it, but now if I look at what I have here, I can actually do some common factoring. So both of these terms divide evenly by 2, and they both have a power of y. So 2y becomes my common factor, leaves me with a bracket of 3x minus 1. So now I actually have factored this. I've broken it up into separate pieces multiplied together. But I had to do a little trick to make that happen. And we can't just do these tricks whenever we want with no consequences. We always have to readjust after we've used tricks like this at the end. And when I say readjust, I mean we can't have any of these y's in our final answer, because y was just something that we made up. We made up this new variable to make this substitution happen. But just in the same way that we created this y, we can also get rid of this y by just substituting back in the other direction. So now I'm going to replace y with x plus 1 again. So now it's going to be 2 times x plus 1. So I'm just substituting in the opposite order now. I'm just sort of reversing my substitution. Substitute x plus 1 back in, and I still have my 3x minus 1. And so I still have a fully factored form. It's still multiple pieces multiplied together, and it now still equals the same original polynomial that I had at the start. Let's try that substitution skill again. And here, now again, you might see something very common and important. So we see an x plus 2 appearing in this bracket. That whole bracket's being squared. We also see an x plus 2 appearing over here. So maybe there's a way we can simplify this by replacing x plus 2 with an individual or single variable. So let's do that. I'm going to say let's let y, and once again you can choose any letter you want, but I'm just going to use y again. Let's let y equal x plus 2 and see how that changes it. Suddenly my expression becomes y squared minus 6y plus 8. I should start with an equal sign, of course. So now what started as a very complex looking polynomial is actually just a trinomial. And in fact, it's a simple trinomial based on this new variable y. So I just need to try and factor that first using the same skills that we learned in our previous lesson. And you can, of course, pause the video here for a second and try it on your own. But I'm just going to go ahead and write down what I found. Would factor in this case into y minus 4 and y minus 2. But again, y was just something that we made up. So in our very final answer, we need to make sure that we now take the y's that we introduced and replace them back to what they originally were. So we're going to replace every y that we see with an x plus 2. And that's tricky because x plus 2 we want to substitute in its own little set of brackets. So I'm going to introduce extra square brackets on the outside of this to make it a little bit more clear. So we have x plus 2. And then remember, inside that same bracket, I still have a minus 4. And I have another x plus 2. And in this second bracket, I still have a minus 2 as well. So remember, the minus 4 in the first bracket and the minus 2 in the second bracket, those are things that were already originally there, and I need to make sure that they continue to be there. But then I actually have a little bit of simplifying I can do, because the plus 2 and minus 4 here are just numbers that can be combined. And this plus 2 and minus 2 are just numbers that can be combined. So my final and simplest way that I can write this factored form is actually, well, this first bracket is x minus 2, and this second bracket is actually just x. And so that's technically correct to write it that way, but by convention, the more conventional way that we tend to write that is if there is an x on its own or a variable on its own that doesn't have anything in a bracket with it, we tend to write it first. So just because I've ran out of room underneath, I'll write it beside. We would normally write this as x and then put the more complex bracket beside it, the x minus 2 beside it. And that's our simplest way that we could write that. Let's keep going and try another one. Now, we're still seeing, hopefully, these same sort of patterns emerging. It's just that the things that we're going to substitute are getting a little bit more complex. So once again, we see a certain thing inside of a bracket, x squared plus 2x. And we have the exact same thing appearing over here. So you probably guessed it at this stage. If you think you know where I'm going with this, try and pause it and do a substitution on your own if you want. Otherwise, just follow along with me. I'm going to let y equal exactly that thing that I just highlighted, x squared plus 2x. So how does this expression look now? Well, suddenly it becomes y squared minus 2y minus 3. If we take a minute and factor that using the skills from before, well, that could factor into y minus 3 and y minus 1. That would work. From there, I need to substitute back in. This is where I'll use square brackets to help me. So x squared plus 2x gets subbed back in, but I still have a minus 3 in that original bracket. X squared plus 2x gets subbed in over here, and I still have a minus 1 inside this bracket as well. So overall, what does that mean? Well, let's write this in a little bit simpler way. In this first bracket, I have x squared plus 2x minus 3. In the second one, altogether, I have x squared plus 2x minus 1. Now, I could say that I've factored it, and in a sense I have, but we always want to factor completely or factor fully, and that's really what this was asking us to do. And so once we have two separate factors like this, we always need to look at our factors and see, can we break them down even further? And if you notice, both of the things we have inside of our two brackets are trinomials, and they can each be broken down even further as such. So the first one can be broken down as x plus 3 and x minus 1. The second one can be broken down as x plus 1 and x plus 1 once again. And just to make this one last little bit of simplified, we can say that this is x plus 3 times x minus 1. And then because there's two copies of that x plus 1 factor, we can really just say it's x plus 1 squared, which is the shortcut way of saying we have two copies of that same factor. Let's try one more of this substitution trick. Because sometimes there may be complex things that we might want to replace, not just with one single letter, but with two different letters. So here we have a 3x plus 1, but we don't have a 3x plus 1 appearing anywhere else, but we do have something different that we might try and replace, an x minus 5. Well, let's try a trick where we make two substitutions. So, for example, and I'm going to choose new letters, let's try A and B. I'm going to let A represent what I see as my blue highlight there, 3x plus 1. I'm just going to call that from now on A. And it's just going to, again, just like we've been doing so far, it's going to simplify this whole thing so that I can think of that entire bracket as one single variable that I'm working with. I'm going to create a variable B and say that that's really what x minus 5 is. And again, that simplifies this to just thinking about A and B as opposed to these more complex things that are inside the brackets. So really, suddenly this becomes 9a squared minus b squared. Well, that's two things that are being subtracted, and each of those terms can also be easily square rooted, which means this is a difference of squares. So that means it would break down into 3a plus b and 3a minus b. If you're forgetting how I did that, go back and review difference of squares factoring from our previous lesson. But again, we can only do tricks like this if we don't have A's and B's in our final answer, because A's and B's don't really exist. We just made them up for the purpose of our mathematical tricks. So we have to go back and substitute back in. And this is where this is going to look a little bit messy at first, but we really just need to continue to expand. So I'll use square brackets again to help me. It's 3 times A and then added with B. So it's 3 times 3x plus 1. And then added with x minus 5. So you can see the importance of keeping those A and B pieces in their own little bracket at first when I substitute them back in. That's really important. And then I'm going to have a very similar looking bracket, but with a subtraction. So it's 3 times 3x plus 1, and then subtracted with x minus 5. And now from there, I can continue and expand this out a little bit. So we would have, for example, 9x plus 3 plus x minus 5 in this bracket, and we would have 9x plus 3 minus x and plus 5 in this second bracket. Simplify down a little bit, and really this becomes 8, oops, sorry. This one would become 10x minus 2, and this one would become 8x plus 8. From there, always look at the two factors you have and see if you can factor any further. Well, those two binomials we have, we can't do any difference of squares or trinomial factoring, but they each have a common factor that I'm going to pull out. So the first one has a common factor of 2 that I can pull out and leave 5x minus 1. The second one has this extra factor of 8 that I can pull out, and that will leave an x plus 1. So now, and maybe I can even, if I want to, just for clarity, keep an extra set of brackets around that. This 2 and this 8 are both just coefficients that can multiply together. And I can put them both out front as just 16 times 5x minus 1, which I have, and x plus 1 as well. For the remainder of this lesson, we'll look at a strategy called factoring by grouping, which in certain situations will actually have a lot in common or a lot of overlap with substitution. And certain situations could actually be solved by either substitution or grouping, as we'll actually see in these very first couple examples of it. So let's look at what we mean by grouping here. Well, grouping means that if we realize we can't factor an entire polynomial expression in one particular way, we ask ourselves, can we group together certain terms and maybe factor 2 or 3 of those terms together in a certain way? So here's what I mean by that. So for example, What I'm going to do with this first one is say that there's no common factors or no trinomial factoring or difference of squares stuff I can do with the 4 terms that I see in 2a. But if I was to look at it in chunks, or in other words, in groups, such as these 2 terms being one group and these 2 terms being a second group, then suddenly if I think about each group has a common factor. So that's what I'm going to do, is I'm going to try and common factor something from each group. So from the first 2 terms, they definitely have a 5 as a common factor. They both are divisible by 5, and they both have at least 2 powers of x. So 5x squared would be a common factor. And then what does that leave? Well, if I divide 5x cubed by 5x squared, I get just x. That second term, if I divide it by 5x squared, I would just get -2. So I have an x minus 2 left over in a bracket. And then from those second 2 terms, well, I can definitely factor out 3 from both of them, but remember the leading term is negative, so I'm actually going to factor out -3 from those. And what does that leave left over? It leaves, once again, x, well, minus 2. So suddenly, I've grouped it, and that grouping has allowed me to do a little bit of common factoring. From there, you might notice something. This is actually a stage where if I wanted to, I could do a substitution. I could say that x minus 2 was equal to some variable, and then do some factoring work with it from there. But now we can actually take a bit of a shortcut, because what we would realize if we were to do that substitution is that what we can then do with that blue highlighted factor there is recognize that that is a common factor. Another way to think of this is that we still have 2 separate big chunks, and each chunk has something in common. The thing that they have in common is that x minus 2 bracket. So x minus 2 itself is a common factor. And so rather than even doing a substitution at all and getting a little possibly confused with these extra letters, let's just pull that out in front, just like we do with any other common factor. And then, what do we do after we common factor? Well, we create a bracket beside our common factor with what's left over when we divide it away. Well, when we divide off an x minus 2 from the first chunk, we have 5x squared. When we divide away the bracket from the second chunk, we have the -3. That is our fully factored form, and we're done. So that grouping at the beginning allowed us to do that. And again, if you had needed to, you could have actually done a substitution, but as you can see, the more of those substitutions you do in these certain cases, you can really just skip over that substitution step. Let's try that again. This one's going to break down very similarly, and I'm actually going to tackle it in the same way. I'm going to break it up by thinking of these 2 terms as one chunk or one group, and this will be another group. So what sorts of factors can I find? Well, for this one, I can definitely pull out 2, and they both have at least 2 powers of x. So 2x squared would be a common factor. That would leave me with just x from the first term, and 4 from the second term. And now this second group is kind of interesting. Sometimes you might run into a stage where one group does factor nicely, like we just did, but maybe the other group doesn't really have any interesting common factors. Well, remember, when in doubt, you can always common factor out a +1. And that might seem a little strange, but take a look at what that'll do. So if I just pull out a +1 and then create a bracket beside, it's really just going to be exactly what I already had, x plus 4. But suddenly, I end up with the same situation that we had in our previous example, where x plus 4 pops up in both of our 2 groups. Both of our 2 chunks or terms have that x plus 4 in common. That means x plus 4 is the common factor, so x plus 4 itself can be written out in front, and we create a bracket beside with what's left over. 2x squared is what's left over from the first chunk, and then the +1 is what's left over from the second chunk. So factoring out, as weird of a step as it was, factoring out this extra +1 here allowed us to figure out what would be the other piece inside of this final bracket when we do our common factoring in that last step. Let's see a couple other ways that we can group things as well that can be even more useful to us in special situations. So in this case, there aren't any good ways to group the terms 2 at a time for this example. But if we look carefully, there might be another way we can group them. In some cases, you can also look for, are there any situations where grouping 3 terms together might be helpful? So that's going to leave this term as its own separate group, kind of lonely on its own, but the other 3, those first 3, actually form a trinomial. And we know that they can actually be factored, actually just like any other simple trinomial. If you spend some time trying to factor that simple trinomial, you'd actually realize that it works out to x squared plus 3 times another x squared plus 3. So really, I'm going to just factor it as x squared plus 3 and square that whole thing. That's really what that first piece factors into. But then we still have a minus 4y to the power of 4 hanging off the end there. But all of a sudden, I actually, even though it looks a bit weird, I have a difference of squares. I have a piece here that's being squared, and I have this piece here that can easily be square rooted because it has an even exponent. So I can easily cut its exponent in half, and I can easily square root that second piece as well. So I have 2 big terms that are being subtracted from each other, and I can easily square root both of them. So I'm dealing with a difference of squares situation. So that means I need to take, the square root of the first piece and subtract it with the square root of the second piece. That's going to make one of my brackets. So the square root of the first piece is x squared plus 3 minus 2y squared. And all I need to do to create the other bracket is just do x squared plus 3 in a bracket and then add that with 2y squared. That, again, is just factoring by difference of squares. And now, as a final answer, we actually can't really do any more factoring of either of our 2 large brackets, the 2 big square brackets. So I'm just going to rewrite this in a bit more standard way. Normally, if there's anything that's just a number with no variables attached, we would write that at the end. So I'm just going to rearrange this and call it x squared. I'll put the minus 2y squared next and tack the plus 3 as the third term, and do something similar in this bracket as well. X squared plus 2y squared and plus 3, and that is our fully factored form in the simplest way that we can write it. Let's try one more of those types where we're going to group 3 at a time once again. So now, again, if you look at this, you can try as much as you want to try and group 2 terms together at a time, or for that matter, you can try any of the other factoring methods that we learned in our previous lesson, but none of those are going to work for you. So eventually you have to think, can I group 3 terms together at a time? Well, grouping the first 3 together won't really do much. There's not a strong relationship that leads to a good factoring idea when we group those 3 together. So instead, why don't I group these last 3 together? Because if I look at those last 3, they clearly seem to form a simple trinomial. And actually, I should be careful here because really those last 3 also include that negative sign as well. So what I'm going to do first is group them together by putting them in their own little bracket. It's like I'm going to factor out a -1. So it's like I'm doing x squared subtract y squared minus 14y plus 49. So I've grouped them together, and to make this thing look more like a regular simple trinomial, I factored out the negative that was in front of the y squared. So that now, all of a sudden, I truly do have a very simple trinomial that I can work with here and factor. So let's do that. I still have x squared coming along for the ride, and then I'm going to subtract whatever I get when I factor that. So if you factor that, you'll realize you actually get y minus 7 times another y minus 7. So the simpler way we can write that is that it's y minus 7 all squared. And now, all of a sudden, once again, we have something that's being squared, something else that's being squared. In other words, two things that can easily be square rooted, and they're being subtracted. So this, once again, is our good old friend difference of squares. So we can write properly. We can create our brackets as follows. So it would be the square root of the first thing subtracted with the square root of the second thing. Something like that. And the other bracket just has to be the square root of the first thing added with the square root of the second thing. And then as a final, slightly simpler way to write it, we can eliminate those extra brackets that we have inside and write it in a slightly simpler way. So we can just say x minus y minus 7 in the first bracket, or sorry, plus 7 in the first bracket when we expand that out, and x plus y minus 7 in the second bracket. That would be our final result. So take some time and make sure that you've tried the homework exercises that go along with this lesson. And in our next lesson, we're going to see why these factoring skills are so important. One of the important uses that we're going to use these for is to solve equations with them. And then our next lesson after that, we're going to see a completely different use for factoring skills. So in general, these factoring skills are going to come up in several different places, not just within this unit, but in future units as well.